In the vast, star-strewn expanse of our solar system, beyond the fiery embrace of the sun, and past the familiar orbits of our interplanetary neighbors, lies a realm of giants. Among these distant companions, one in particular captures our imagination like no other. This is Europa, the fourth largest moon of Jupiter. It is a small, unassuming world, swathed in a brilliant shell of ice that gleams in the faint sunlight. Its surface, a chaotic jigsaw of fractures and ridges, hints at a dynamic and active history. Scientists believe this something is a vast, hidden ocean of liquid water, a body of water so immense it could hold more than twice the volume of all the oceans on Earth combined. What makes Europa so utterly captivating is this single, profound question: could life exist there? Europa challenges our terrestrial biases, presenting a scenario where life might thrive in the crushing pressure and eternal darkness of a subsurface ocean. Our fascination with Europa is not a new phenomenon. It is the culmination of centuries of observation and decades of dedicated scientific inquiry. For centuries after its discovery by Galileo Galilei in 1610, Europa remained little more than a tiny, unresolved speck of light. It was only with the advent of larger, more powerful ground-based telescopes in the 20th century that we began to scratch beneath the surface, metaphorically speaking. By analyzing the spectrum of sunlight reflecting off Europa, astronomers detected the unmistakable signature of water ice. The first to arrive were the twin Voyager 1 and 2 probes in 1979. Though their encounters were brief, high-speed flybys on their way to the outer solar system, the images they sent back were revelatory. The true golden age of European discovery began in 1995 with the arrival of the Galileo spacecraft. With its suite of advanced instruments, Galileo peeled back the layers of mystery one by one, providing the smoking gun for a subsurface ocean. The most visually stunning features of Europa's ice shell are the intricate networks of lines that crisscross its entire surface. These are vast geological formations known as lineae, giving the moon the appearance of a cracked eggshell. Beyond the individual cracks and ridges, there are much larger and more chaotic features. These regions look as if sections of the icy crust have been shattered into a jumble of rafts and icebergs, providing compelling visual evidence for a liquid layer not far below. Beyond the visual clues, Europa provides another, more subtle line of evidence for its hidden ocean. The Galileo spacecraft detected that Europa has its own weak magnetic field, an induced magnetic field created by a conducting material moving through Jupiter's magnetic field. In the cold outer solar system, the most plausible candidate by far is a salty, liquid water ocean. The presence of this induced magnetic field is considered by many scientists to be the single strongest piece of evidence we have for Europa's ocean. Perhaps the most exciting and direct clue pointing to a subsurface ocean is the potential discovery of giant plumes of water vapor erupting from Europa's surface. In 2012, astronomers using the Hubble Space Telescope spotted what appeared to be faint emissions of water vapor rising high above the moon's southern hemisphere. If they are sourced directly from the subsurface ocean, they are essentially giving us a free sample of what lies beneath the ice. A future mission could taste the ocean, searching for complex organic molecules or even the chemical fingerprints of life, all without ever touching the moon's surface. Europa is far from the sun, drifting in the profound cold of the outer solar system where temperatures are far too low for liquid water to exist naturally. The answer lies in a relentless gravitational dance with Jupiter, providing a constant source of internal heat through tidal heating. This constant cycle of stretching and relaxing generates tremendous friction deep within Europa's interior, creating heat that keeps the ocean from freezing solid. This internal engine, born from gravity, is the key to everything that makes Europa so compelling. Based on the magnetic field data and surface composition, we can paint a picture of a global ocean of salty liquid water in direct contact with a rocky sea floor. The most exciting possibility is that tidal heating could power hydrothermal vents on the ocean floor, providing the energy source needed to sustain a biosphere. So we have the three key ingredients that scientists believe are necessary for life: liquid water, essential chemical elements, and a source of energy. Europa's ocean appears to have all three, making it one of the most compelling targets in our search for extraterrestrial life. This new era of European exploration is already underway, with two major missions poised to rewrite the textbooks: the European Space Agency's JUICE mission and NASA's Europa Clipper. These missions are equipped with sophisticated suites of instruments designed to measure the thickness of the ice shell and analyze plumes of water vapor. The goal is to search for biosignatures, any substance or pattern whose origin specifically requires a biological agent. The hunt is on, and the secrets frozen into Europa's ice may soon give us the answer we've been searching for. Europa represents more than just a target for scientific investigation. It embodies a fundamental shift in our search for life beyond Earth. The discovery of even simple microbial life in Europa's depths would be one of the most profound scientific revelations in human history. This small, bright moon, orbiting its giant parent in the cold and dark, beckons us forward, promising to reveal not just its own secrets, but perhaps the most important secrets about ourselves. The search continues, and the truth is waiting.